Rational inequalities. A rational number is any number that can be expressed as the quotient of two integers, a over b, where a and b are integers. Similarly, a rational function is one that can be expressed as some function p divided by another function q. A point of interest here. Whenever we are dealing with rational functions, we are always interested in the values of x that make the denominator, in our case the q of x, equal 0. Now, the first rule for solving rational inequalities is that one side of the inequality sign must be equal to 0. The other side of the inequality sign must be expressed as a single fraction in the form p of x divided by q of x. The method for solving rational inequalities is as follows. Step 1. Rewrite the inequality, if necessary, so that it is of the form p of x divided by q of x is less than or equal to 0. And remember that any of the inequality signs will work. Step 2. Determine the values of x that make the numerator and the denominator 0. These numbers identify the intervals to be considered on the real line. The intervals are open or closed depending on the inequality. The values of x that make q of x equal 0 are always open intervals. Step 3. Use a test point in each interval to determine which interval is true for the original equation. Example. Solve the rational inequality 4 divided by x minus 2 is less than or equal to 3 divided by x minus 1. Step 1. Rewrite the inequality as follows. 4 divided by x minus 2 minus 3 divided by x minus 1 is less than or equal to 0. We can simplify this expression to get it in the form required by putting 4 divided by x minus 2 minus 3 divided by x minus 1 over a common denominator. We get 4 times x minus 1 minus 3 times x minus 2 all divided by x minus 2 times x minus 1, which equals 4x minus 4 minus 3x plus 6 all divided by x minus 2 times x minus 1 is less than or equal to 0. Further simplifying, we get x plus 2 divided by x minus 2 times x minus 1 is less than or equal to 0. Step 2. To make the numerator 0, we put x plus 2 equals 0. That gives us x equal negative 2. To make the denominator equal 0, we put x minus 2 times x minus 1 equals 0. Using the zero factor property, then either x minus 2 equals 0 or x minus 1 equals 0. When we put x minus 2 equals 0, then x equals plus 2. When x minus 1 equals 0, then x equals plus 1. The points on the real line are x equals negative 2, x equals positive 1, and x equals positive 2. Since the values x equal plus 1 and x equal plus 2 make q of x equal 0, then x cannot take on these values. That makes the interval with these values open. There are 4 intervals to consider: A, B, C, and D. Interval A is between -infinity and -2. It is open at -infinity and closed at x equal 2. Interval B is from x equal -2 to x equal +1. It is closed at x equal -2 and open at x equal +1. Interval C goes from 1 to 2 and it's open on both ends. And interval D goes from 2 to infinity, and that is also open on both ends. Choosing a point from each interval, let's choose the point -3 from interval A. The original equation becomes 4 divided by -5 is less than or equal to 3 divided by -4, which is true. In interval B, let's choose x equals 0. The original equation becomes 4 divided by -2 is less than or equal to 3 divided by -1. Or simply put, -2 is less than -3, which is false. In interval C, we choose x equal 3 divided by 2. The original equation then becomes 4 divided by 3 minus 2 is less than or equal to 3 divided by 3 minus 1. Or simplified, -8 is less than or equal to 6, which is true. In interval D, we choose x equals +3. The original equation becomes 4 divided by 3 minus 2 is less than or equal to 3 divided by 3 minus 1, or simply put, 4 is less than or equal to 3 divided by 2, which is false. The solution, therefore, is the union of interval A and interval C. Now, interval A goes from -infinity to -2. It is open at -infinity and it's closed at x equal -2. It is closed because x can take on the value -2. Interval C, on the other hand, goes from +1 to +2. In this case, this interval is open. The interval is open because the function cannot take on the values x equal 1 and x equal 2. Now, in this solution, we have introduced a new term. The solution is the union of interval A and interval C. Now, what is this union business all about? Well, the union of interval A and interval C simply means that x could exist in interval A or in interval C. That's all that union means. X could be in interval A or x could be in interval C.